All right. I know not everyone's familiar with Salesforce Connect, right? It is an additional license from Salesforce. I'll talk through what it is a little bit, although I am going to skip past. This is a Dreamforce deck. We've got the forward-looking statements. I was surprised until the day of presentation. I had "or dinosaurs" at the end, and nobody caught it in all of the reviews. But I didn't want to get anybody in trouble. So I presented this at Dreamforce with Ross. Ross Belmont, you'll see him posting regularly. He's the product manager over a number of things with external data sources, with AWS, and with named credentials. And if you've looked at named credentials lately, they're different now. They're really different than they were before the winter release. Ross is a great guy, and he's been very accessible. I see him posting on LinkedIn and posting at Medium. Okay, here we go. Salesforce Connect is about virtualizing data. If you haven't worked with Salesforce Connect before, you probably haven't worked with what's called external objects in Salesforce. Salesforce Connect allows you to use the standard Salesforce user interface, standard SOQL, and depending on the adapter, standard reports and standard search as well, to interact with data that does not live in Salesforce. So your end users don't know that the data is not stored locally. It's being pulled from some outside data source. Sorry, these are Ross's slides. All right, here we go. Here's where I can really start. I'm working as the Salesforce platform architect at Compassion International. Compassion is a large nonprofit that is releasing millions of children and their families from extreme poverty around the world. So all of those blue markers on the maps, those are the program countries. There are over 2 million children that have a one-to-one sponsorship with a supporter in one of the countries that's labeled with a yellow marker. This gets complicated with technology, but the technology is essential to do what we do. So 8,500 church partners that run this child development center program all around the world. So I want to tell you a little bit about my involvement with Compassion. My family and I, we have sponsored children with Compassion long before I worked there. I'd like to introduce you to Aurora. Aurora is a 6-year-old who we sponsor in Rwanda. Now, Aurora writes us letters and sends us drawings. These are all digitized and sent to us in a digital form. I print them out and I give them to my children, who you can see are somewhere up a tree. If this were a picture from today, it would be snowy and they'd be more bundled up. This was from the summer. Well, they draw pictures and write letters back. And there's a relationship formed of writing letters back and forth. And we have sponsored children, some kids that we have sponsored, we've seen them go from like 8 years old to 20 years old when they wrap up the program. And instead of living in extreme poverty, they're off to university. And this relationship is amazing. With us, I checked the system. Throughout our history, there's about 160 letters that have gone back and forth between my family and children that we have sponsored through Compassion. Altogether, there's more than 43 million letters that have gone back and forth. All of these have a data record in Salesforce. I'm talking about a database record. I'm not talking about file storage. There are other options available for file storage. That's not our use case, but this is a large data use case that we need to sort through. If you're like me, you've probably heard somebody who makes decisions say something like this. Well, if it requires data, we can't use Salesforce. It's too expensive or it's too complicated. Well, there's new things available for working with large data. Everywhere that I've been working with Salesforce, data storage has been a concern. Is at some point, once you're over 100% of your data storage, you'll get a call from your account executive saying, okay, it's time to pay up. Right? You have a certain amount of time to cut back on your data or to purchase the additional data allocations. I built proofs of concept for how we could start archiving these letters using various different technologies with Salesforce. Big objects actually would have worked in this use case. If you haven't worked with big objects, like me, I hadn't worked with it before. I think it's a $_B for big, all right, instead of for a big object, instead of a $_C that you're used to for custom objects. It's real limited in how you can access that data via SOQL, and the records there cannot surface in the standard Salesforce user interface on a related list, which is what we wanted to do. Here, what I really wanted to do here is say, hey, old letters, I want to archive them so they can still be accessed in Salesforce. We can still see that information about the letters in Salesforce. And we have an API from outside that queries for these letters. So I have to be able to access them from Apex via SOQL. There are third-party tools that are fantastic for archiving data. but they're third-party tools. They have a custom user interface with a visual force or lightning components to show those records on the screen. And I have yet to find a tool that I could access that data programmatically to serve that API that I needed to serve. I've used the Salesforce Connect Apex adapter, which is really flexible and I think a lot of fun to virtualize data into Salesforce from outside data sources. It's not as easy to maintain and it's not as scalable. We've got one of these adapters that we've used at Compassion. It's a big lift to expand this to additional use cases over what it's been used for today. And then the last option is just delete the data. There are plenty of use cases where deleting the data is the right thing to do. But if it's valuable data that's worth maintaining over time, deletion just wasn't an option. Then I found out when I was at TDX earlier this year about the new Salesforce Connect adapter for Amazon DynamoDB. I didn't know about DynamoDB, but I started asking questions, and it's really nice for this use case. And it checks all the boxes, right? Standard user interface. We can access the data via SOQL, and we can modify and manage the data with DML, as well as through the standard Salesforce interface. It is easy to maintain, and it's scalable, and it's cheap data storage. I've always said Salesforce is not, Salesforce is a lot of things, but it's not cheap cloud storage. Until now, because now with this adapter for Salesforce Connect, I think we've got Salesforce with cheap cloud data storage. So just a step back on what is Salesforce Connect. This creates external objects in Salesforce, right? Standard objects don't have a suffix. Custom objects have C. Big objects, I think, have B. External objects have X, right? So if you look at the API name of one of these objects, it'll be a _X. There's different adapters. Salesforce first came out with an OData 2.0 adapter, which was read-only for OData sources. Microsoft and SAP collaborated to create the OData standard for REST APIs. OData 4.0 introduces the ability to have full read-write access. Custom Apex is really nice, and I'd be happy to chat anytime about what I've done with custom Apex adapters before. You can reach all sorts of different data points because you control the adapter to virtualize that data into Salesforce. And new is DynamoDB and Athena from AWS. Different capabilities for different use cases. For what I'm looking at, DynamoDB was the right fit. And I think the most brilliant thing here is it's the standard Salesforce user interface. And we'll take a look at that. Now, here's the code that's required to connect Salesforce to DynamoDB. Please don't grab a screenshot. This slide's a joke. There's no code required. And this is what's so nice about this adapter. The integration itself is handled. I had to write 0 lines of integration code to send data over to DynamoDB, 0 lines of code to pull data back into Salesforce from DynamoDB. Now, there is custom code that I wrote on top of the adapter, but the integration itself, there was nothing for me to build. So I'm going to close the presentation and jump into Salesforce and show you how easy it is to connect and virtualize data from DynamoDB into Salesforce. This is AWS. This is a DynamoDB database. The table name is Dreamforce Demo. There's only 3 pieces of data that we need to virtualize this data. First is the table name. Second is the partition key. Third is the sort key. Now, I'm going to start configuring this, and I'll do my best to keep things interesting as I go. I already have the external data source configured. Well, the external data source for AWS, we're going to call this Denver Dev Demo. Dev Demos. The new AWS connections, they work with a new type of named credential authentication that's specific to AWS. There's some documentation around that. And I didn't present on that at Dreamforce because they just changed the way that named credentials work. Now I've got this table that I've added as an external data source, or sorry, external data table off of my DynamoDB external data source. I need to create the table and add those partition fields. Now with DynamoDB, the partition key is a shared thing. Multiple records can and should have that value. This is what AWS uses to store the records physically together. Now, sorting is one complication with DynamoDB. DynamoDB is a NoSQL document database, so there's not rows and columns for everything. So they've got a query layer on top, but not every field can be sorted. So as I create these fields, you'll see I often say don't sort by don't allow sorting on this field. This screen, just a quick shout out to permission sets. In this org, I've enabled field level access at the permission set level rather than the profiles. I'm excited about this because it makes field setup by permission sets much easier. That is unrelated to Salesforce Connect and DynamoDB. All right, now I've got my partition key. Next, we're going to add the sort key. By default, the sort key is the only field that's sortable. So that's a limit as to what data sources are a good fit for DynamoDB virtualization. Now, there are secondary sort keys that can be configured in AWS, but that's not part of what I'm going to demo today. Now, I've got a partition key and a sort key. The combination of those is the unique identifier for that row of data. So the idea is the partition key, that can be shared. The sort key, that you'd want that to be unique within that partition. We're going to add some additional fields. And this was the first thing I did when I got a connection to DynamoDB. I said, all right, DynamoDB knows nothing about the Salesforce account. I'm going to create a custom field on this object that's a lookup to the account and see what happens. I'm just going to go ahead and add it to all of the account layouts. And we'll add another thing as well. Let's see how pick list fields work on an external object. All right, let's see. Who do we have here? I see Doug, Becca, Paul, and Lauren. This is my proof that this is a live demo. Now, I'm going to disable sorting on this field because I'm not going to configure this as a sortable field in AWS. Filtering is enabled. So Salesforce filters, list view filters, they work on this sort of data. Something I'd love to archive are old call logs for our call center, and being able to sort those is, I think, less important than being able to filter. Well, show me the calls for this customer between these two dates, right? That sort of thing would still work because every field is still filterable. Now, over on the external data source, there's an option called validate and sync. Now, for the other adapters until now, for the Apex and the OData adapters, validate and sync would create the external table with all the fields. So this is backward. Like, this is a little bit different than those because I have to create the table first with that partition key and with the sort key. And then this validate and sync makes sure that everything matches up with those two required fields. I can continue to add more fields through the setup menu in Salesforce for that external object, but the partition key and sort key have to match what's in AWS and then that sync button work. Now look, here we go. I've got my Denver dev demos related list right here. Standard Salesforce UI, right? I've written no code. Now I'm just going to throw some random strings in here for my partition key and my sort key. This is an account lookup field, right? This will work like any other account lookup field where I can pick through the standard Salesforce UI and I can pick from the devs on the top of my screen on the call. And here we go. This record does not live in Salesforce. This has taken up 0 rows of data in Salesforce. And I created it through the standard Salesforce user interface. If I go back to that account, I can now see it on the related list and I can configure the fields. And the hovers work. Everything works on this. I can come in and I can edit this record through the standard Salesforce user interface and say, I'm going to change from Doug to Paul and save that record. Now, back in AWS, what does this look like? I did not tell AWS about an account field or a demo devs field. It dynamically presents these. This is just how DynamoDB works. So if this was a locally stored object in Salesforce, this is how the data would be stored. But this opens up new possibilities. What if something else was modifying this data in DynamoDB? Then what happens? So if I change that to Becca, let me come back over here and reload my account screen and take a look at that related list. Oh, I don't have that field on there. All right. You can see the fresh view pulls in Becca because the data is not stored in Salesforce. Salesforce doesn't even cache the data used via Salesforce Connect. Now, it does cache one thing. It caches the external ID. What you'll see up at the top of my screen, you can actually see the Salesforce ID for this record. Sorry, so it starts with an X because it's an external object. This is the 15 to 18 character ID that we're used to. All that Salesforce caches is its ID and to the external ID of this record. So for DynamoDB, that's the combination of the partition key and the sort key. So it does cache that, so it can use its own ID wherever its IDs are used. Well, let's see. We've created, we've modified, and we can delete. So now that record is gone. And if I come over and refresh my, there's no data left in this table in DynamoDB. So this is the no-code way of connecting Salesforce to DynamoDB. DynamoDB is what AWS uses for Prime Day, right? It's high-performant, huge amounts of data. So this is where the billions of records comes from. This is the technology for storing huge amounts of data without the exorbitant cost that you would get to try to store a billion records in Salesforce. So then I thought, well, listen, here's an example of a bunch of letters, and I want to write a script, a piece of code that iterates over these records to archive them. So I'm just going to run this script that I wrote, and then we can take a look at the code. This is a screen flow here, but all it's doing is calling a piece of invocable Apex to kick off the batch. What I want to do is just have this run once a night and archive data that meets the criteria. We'll walk through how I built this in just a minute. I'm going to hit run archive batch job. And it's kicking off that batch class right now. So if I refresh my view of the account, the first thing it does is it copies the data from Salesforce to DynamoDB, and then it deletes the local copy of the data, because that's how archiving works, right? It replicated the data, and then it deleted the local copy. So you can see that any records with a communication date before 8/18 have now been copied over to DynamoDB. So let's take a look at how different these records are. I'm going to open up one archive letter and one locally stored letter. So here's the locally stored letter. We've got a couple Lightning components on here that are to update a related record, right? This is the related record Lightning component, standard Salesforce. And then we've got our page layout. And you can see we've got the account field, and there's fields of different types, right? We've got date fields. Here's a URL field. Now let's look at a letter that's not stored in Salesforce. Here it is. The same Lightning components work to update a related record. So I could modify the supporter or the participant details from here, standard Lightning components. Now, if you're looking closely, you're going to see some HTML. These were rich text fields on our custom object in Salesforce. Rich text is not a field that is configured to work with the DynamoDB adapter. So I just turned those into large text fields, but it's copying the values right from one to the other. So there are HTML values that show up. Now, other things that are going to work on an external object, master detail relationships, right? That's how you get roll-ups. Well, you can't roll up the data that doesn't live in Salesforce. Formula fields, you can't create a formula field, right? Because that's Salesforce running those formula calculations on the fly. But this data doesn't live in Salesforce. But here on this external object, here's my favorite thing that I discovered, because I just copied the schema from the custom object to the external. Dependent pick lists work on an external object, because this isn't dependent on the database that it's stored in. This is just dependent on how this object is configured within Salesforce. Now, I built this piece here, delete letters for this supporter. I just built that in so I could reset the demo. But what's nice about this is I've got a flow that's just running delete records, and it's running it twice. It's running one for external data and one for local data in Salesforce. So while you couldn't have a record triggered flow on external data, flows can work on external data, right? A flow, a standard Salesforce flow with no code behind it, just modified those records, deleted those records in DynamoDB. So that's what I built. Now, how did I build it out? I'm a big fan of custom metadata types. So here's my list of archive settings for this job. The first row here is we're going to archive letter. Let me zoom in a little bit. The custom object called letter, we're going to archive to an external object that has the API name of archived letter. And then I've built an aware clause, right? So my batch class is going to iterate over this, build a query, and find all the letters that match this criteria, where the communication date is less than the last 90 days. The second row I have here is to archive old tasks that are more than a year old. I don't know if anyone else has been bitten by Salesforce's archiving of old tasks. I have repeatedly. you're still paying for all the data storage of having those tasks in the system, but you can't run standard reports on them. Related lists in communities was wonky the last time I tried to use those for archive tasks. But let's just talk letters for now. I'm going to pull up my sorry, my Windows needed updates right as this meeting was about to start. Here we go. All right. If I take out the comments and some things we're not going to cover, it's about 75 lines of Apex that runs the whole data archiving from Salesforce into DynamoDB. It's really small. So this is a schedulable batch class that allows callouts, which I think is required because in the background, right, this adapter is making a callout. The first thing that happens on the scheduled basis is that, right, this execute with a schedulable context is it iterates over those custom metadata settings. We just looked at those. And it says, all right, for each one of those metadata settings, we're first going to get all of the fields for the source object, because we want to query every field from the source object, because we're going to want to copy all of those fields over to the external object. It builds a query, and if the where clause is present, then it adds that out, right? So all this is doing is creating a string that's a query to place that SOQL against the database in Salesforce. It passes that and the metadata type record to the next method, to the batch class, batch archive objects. Now, it's the same class, right? Batch archive objects. This is schedulable and batchable. So now we get down to the batchable part of the class. Now, this is going to work as a batch, right? Standard 200 records at a time over that query. So it starts, right, which is just getting that query locator, the standard batch class. We're not going to go into the guts of what a batch class is today. The execute method is where the meat of a batch class is. You can see it only does two things. The first thing it does, I wonder if I should, can everyone read it? Is it too small? I can zoom in. I just realized I hadn't zoomed in.
I think we can all read it.
All right, okay. So it's real simple, right? If replicate objects returns true, then archive objects. All right, so that makes sense, right? We're going to replicate the data, and if that works, then we're going to delete the local copy. So here's how replicate objects works. It's getting every field from the destination object, that external object in Salesforce. This is about the, yeah, it's about the same line of code as we saw up above for the local or for the custom object. We're doing the same thing for the external object here. Now, if that external object has no fields, we're going to stop. It's not really configured. It's not right. It's not ready to go. So it doesn't do anything else. If there are fields, then you'll see it goes over all the fields. This method is really helpful to not iterate over null values. Get populated fields as map. Goes over all the fields on object number one, right, on the first letter, field by field. It's looking to see, hey, do we have a matching field on our external object, right? So I say communication date. That's going to be communication date _ C. So if that's an exact match, then it's going to copy it over. Well, what do we do for a standard field like a created date or last modified by ID if I still want to archive those? Well, that's what the second if statement is for here. If it does not end with the custom suffix, then we're going to compare the standard API name to the standard API name with that suffix. So created date _ C would be a match for the sake of this code. And it copies those records over, or it copies the field data over, and then adds that object to a list of archive objects to insert. And then it inserts the object. This is the whole integration to AWS with DynamoDB, database.insert_immediate. Now, you're probably used to, if you write Apex, database.insert. External objects have insert immediate or insert async. So you've got to use one of those. I wanted the results right away. So I said insert immediate, and then we can iterate over the results. You can see all I'm doing here is debugging those results. You can go row by row and validate that every row of data was inserted successfully. I have all of this inside of a try catch. So if there's any exception, it's going to fail, and then it won't delete any internal data. More could be done here to go row by row. But if there's no exception, this returns true. And as we saw above, then it calls the method archive objects, where it deletes the scope, which is the internal data. So that's how this schedulable batch Apex works, and it's scalable. This spins up a separate batch execution for every object that needs to be archived. So that's how this demo works, and it's functional. We watched it work. Now, the next, I'm going to get ahead of myself. So let me pull my slides back up here real quick. And when I'm done with my slides, I'm very happy to go back through anything if we have time and we have questions. All right. Yeah, so just real quick review. Custom metadata is what I use to determine which internal object gets archived to which external object. And then that schedulable batch class. So number one, build the query. Number two, in the batch, right? Copy the data field by field from one object to the other. And then the third step was delete the local data if that was all successful. I want to talk about qualifiers. Qualifiers was a new concept for me. This has to do with that second row of custom metadata, archiving tasks. Task, there's multiple pain points around tasks in Salesforce, right? If I say what ID and who ID, does that make sense to anybody on the call? These are polymorphic lookup fields. A what ID, a task can belong to an account or a case or all sorts of things. And the API name of that field is the what ID. But that one field works with related lists on all of those objects. You and I, we don't get to create polymorphic lookup fields, but I wanted to archive the tasks and surface it still through the standard Salesforce API. And we already talked about the pain of Salesforce's archiving of the tasks. Certain things just don't work once a task is a year old. Well, the answer to this is what's called qualifiers. So here's what I built up. Just like letters, right? Letters was a custom object that had a parallel object that I configured for DynamoDB. I did the same thing with tasks. So I took all the fields that were on tasks, I created on an external object. Now, I don't have a demo for this or code that I'm ready to look over for this one. I did this programmatically using the metadata API, iterating over any recently created fields and automatically creating those before this archive runs. So if you create a new field on the letter object, it'll automatically be created on the external object configuration in Salesforce through the metadata API, and then that data will automatically copy over. So it's a self-maintaining parallel object, right? But it's the object configuration because DynamoDB doesn't care what fields you create. It'll just store whatever you insert or update into it. Okay, sorry, back to my slide. So I've got a standard object that's task, an external object with the exact same setup, except that the what ID is just an 18-character string in this setup. I created another archived task object that was specific to accounts. The only thing that's different is that the what ID here is configured to be an external, or it's configured to be a lookup to the account object, but it points to the same table in DynamoDB called archive tasks. I created another one for cases because those are the two places that I want to be able to resurface these tasks on related lists. So then I added, so I've got 3 external objects configured in Salesforce that all have the same table name in that configuration. So they all point to the same table in AWS. I added a qualifier that said, well, the what ID for archived account task has to start with 001. Well, that's the first 3 characters of every account ID. Well, 500 is the first 3 of every case, right? So this way, I can archive the data through this generic archive task external object that's stored in the archive task DynamoDB, but a SOQL, a related list, that here, if it's against the archive account task, it's going to return only the records that the what ID starts with 001. So this is what a qualifier looks like. You can see this is all AWS language, right? There's no external object like API name in here. What happens is the adapter in Salesforce for DynamoDB effectively adds this as a filter to every query that happens, whether it's through SOQL or whether it's through the user interface, to add on, and the column that's called SF part key, it's the partition key for this object, that has to start with 001. So it adds that filter onto the query. So no results will ever be returned unless they match that. Then we can archive tasks even in Salesforce. There's additional use cases that came up. I'm not an AWS guy. So as I started talking to others, I thought I was going to get a lot of pushback. I would hear why this is a terrible idea. Instead, people started to say, well, what other data could we archive? data that maybe we need to reference sometimes in Salesforce, like on the screens, but we don't need it operationally. We're not firing triggers off of it, for example, or running reports. What about huge amounts of data that we have and have never been able to store in Salesforce just because of the huge amount of data that we have? Well, we can do that now, right? That's sort of what I started with. The data on that demo object that I created, that data never lived in Salesforce. And well, I guess that's the last one. New objects, brand new objects, full CRUD access. Now that's CRUD is create, read, update, delete. The users never need to know that that data is not stored locally in the Salesforce database, that is stored in an AWS database instead. User interface remains exactly the same. There are a couple limits, which I'll talk about next. Now, there's really interesting integration options as well. I just saw on the Salesforce Architect website that's a pattern that they call a claim check, where one piece of data is sent across to another system, which it can then use to reference that data, right? To say, oh, you sent me, there's a record number 5. Now I'm going to go place an API call to request record number 5. We've got some interesting use cases coming up on, hey, let's just throw the external ID of a DynamoDB record into Salesforce. We can use code, we could use screen flows to surface that data and perform some logic on it without having to replicate all of it. I'm a big fan of data and trying to keep huge data sources in sync. And this is a solution that really helps with that. So there's good reasons to still keep your data in Salesforce. Your core CRM objects, Salesforce has put all kinds of functionality on top of those. Those are always going to stay in Salesforce. Now, could you say, well, hey, the campaigns from 10 years ago, did those still need to stay in Salesforce? No, but if your record retention policy says you can't actually delete them, you need to keep them somewhere, well, sure, I'll archive them over to DynamoDB like I was just doing with our letters. The field level data, it's probably a bad idea to say, well, half of this object is going to live locally in Salesforce, and the other half of the object is going to live in DynamoDB, and then we'll do a bunch of custom development to present it as if it's one object in Salesforce. Yeah, I wouldn't. It's possible. I wouldn't suggest it. Now, sorting beyond indexes. That's it. Just part of how DynamoDB is designed. Where not everything is sortable. If you need sorting beyond the indexes, beyond that sort key, beyond the secondary indexes that are configured, probably a bad idea to put it in DynamoDB. So far, search and social don't work with DynamoDB. I was asked to say that it's coming soon when the product manager and I got on stage. He said, "Kid, there's stuff coming. I can't tell you what it is yet, but we're getting close." So it's really encouraging to me. Right? There's a lot of work that's going into this. It doesn't work with reports and dashboards though. Standard joins don't work with DynamoDB, and the reports and dashboards require those. I know I can't do a join in SOQL either, but Salesforce can with their reporting tools. So they don't work with standard reports and dashboards. We already talked about the field types, right? Rich text, formula fields, and master detail. Complex criteria-based sharing rules. Listen, Salesforce can't prevent a response coming. It can't prevent a record from coming back in a query based on the data when it doesn't know what that data is. Now there are, I'm forgetting the technical term here. There are like negative sharing rules where like there's negative sharing rules. Somebody can help me with that if anybody remembers, where you can suppress results from being surfaced. Those are fairly new and I haven't used them yet. But of course, if you need to trigger something, if you need to have an Apex trigger or a record triggered flow or an approval process fire on a data point, well, Salesforce has to know about that data when no one's looking at it, right? This DynamoDB stuff is great when your code is looking at it or when a person's looking at it. But those automated things aren't going to work. Now, we also touched base a little bit on event relays. That's not the topic for today, and I don't have nearly as much to show. So I'm happy to wrap it up here. I'd love to take any questions. If anyone has any thoughts, or I'm happy to talk about the other Salesforce Connect adapters as well. The Apex one is really powerful if you like writing code. But that's it. That's what I have for Salesforce Connect and DynamoDB.
So, Jonathan, there was a question in chat about record-triggered flows.
I am not.
Which basically, can you do something like that?
So, the DynamoDB records will never trigger a flow. All right, so a user can trigger a flow, right, by visiting a page where you've got a flow, or by clicking a button to open a flow. You can operate on external objects, including querying them, right, and modifying them or deleting them from a flow. But the record triggered flow has to be on data that is stored in a standard object or a custom object of Salesforce. I have used Salesforce Connect to synchronize, like to pull data in from an outside data source with like a cron job, scheduled Apex. You could do something like that, where you, but I get that would be a scheduled flow or a scheduled Apex to run sort of a recurring query to see if you've got the data that you need to trigger on.
So you mentioned that DynamoDB is a document database. Can you store something in like a file, like a WAV file or a JPEG?
I have not used it to store files. Jim, do you have any insight onto this? Did I get my terms wrong, or should we be thinking of document database differently?
It's a NoSQL database. It's not technically a document database. It's a NoSQL database, and you wouldn't store binary objects in it. No, you would put the binary object somewhere else. In this instance, you would probably want to put the binary object in an S3, and then put an S3 reference in the DynamoDB in one of the DynamoDB fields to pull it back.
Got it.
From the AWS standpoint, yeah.
And correct me if I'm wrong, what DynamoDB is doing with all of these fields that I created in Salesforce and never told Dynamo about, it's really storing those as a JSON document, right, as a big old JSON thing in one column of its database. But it's abstracting that to return them as columns when I query for them as columns or when I write to them as columns.
They're actually called attributes from DynamoDB. Everything in there is an attribute in DynamoDB, even the primary keys, but they have special meanings to them. But yeah, they're just attributes, and you can have dynamically created attributes. It doesn't matter. And the records that, like, if you added a new field, the records in there before would still have that field, but it would be a null value. It would that attribute gets added to essentially every row, but they're nulled in anything that existed before.
And do you know how Salesforce prices Connect?
Yeah, so Salesforce, they've got an interesting pricing model. Each adapter is a cost. Now with OData, your adapter is tied to one URL, right? So if you've got your Microsoft database out there and it's got all the tables in one place and it's got an OData adapter on it, or if you've got SAP and you're using SAP NetWeaver Gateway and it's configured to work with one URL, that's fine. That's one connection. The first time I implemented this, it was to connect our our homegrown customer ordering system to Salesforce, and then we supported North America. We found out that Canadian customers had a parallel server. Everything was identical, but it was on a separate server. That would have meant a separate Connect license, just to hit a different URL, and then every external object would be different. Yeah. Good luck writing queries that way. That's when I switched over to an Apex adapter. I wrote my own OData interpreter to be able to pivot based on the current user to change the URL that all those APIs were going to. There's documentation out there on how to build the Apex adapter. Effectively, it abstracts the query that comes in. So you have to understand the query, and then you have to return the rows of data in a certain format that Salesforce is expecting. But what you do in between, it's up to you. So I hit two different endpoints depending on the locale of the current user. But then I was like, hey, if I'm virtualizing data from anywhere, I'm going to hit the FedEx SOAP API. I'm going to hit the Purelator REST API. We're gonna start virtualizing data all over the place. Now that's all just within that one adapter, right? Because once it's an Apex adapter, it's up to you.
Got it.
I don't know retail pricing, so I can't help with that one.
Got it. Another question in chat. Advice on Athena S3 versus DynamoDB.
I'm going to use my my phone a friend again because these are AWS questions and I have no idea. Jim, I don't know if you have any thoughts on that one.
The main difference between Athena and DynamoDB is Athena is designed for analytics, so the connector is essentially it's a read-only connector. It's not a true CRUD connector because you're gonna put data into it, so it's really technically right. You're gonna put data into.
I'm muted. Did I mute?
No, we can hear you.
So it can be a bidirectional. Then we can store like a retrieve, store back at a real time. Is that available? Is there any like a latency and what is the guaranteed like a record gonna store, or if it fails, does it roll back? What happens if we are doing a real time?
With the DynamoDB,
Yes.
that is all handled by the combination of Salesforce and AWS. And I believe Salesforce, when we were talking to, I can never remember his name at Salesforce, he said there's some retry logic that they take care of that on the Salesforce side. If there's any kind of disconnection between the databases.
How is the security model works? Yeah. How is the security model works? Suppose in Salesforce, like I do not wanted some records to be visible to some users. How is this DynamoDB works in that instance?
Okay, so this one, Salesforce is just in the middle of changing. With the Winter 23 release, which I think we all have now, they've done something new with named credentials, where credentials, the new way, require a permission set, and there's specific permissions in that permission set. So you can assign different people different permission sets that line up to, and Jim, you could probably help me with the term here, the permissions configuration within AWS. So the same adapter, right? All the same external objects and everything, but it's going to go by those user permissions as determined by that permission set.
Yeah, it uses a role on the AWS side. So there's a concept of roles that you can assume. So the way it's built, I've been working with Jonathan on this. The way it's built in Salesforce is you tell it which role you're going to assume when you connect to AWS, and then the permissions for the AWS DynamoDB is based on that role. So you could say, I want to create a role that is a read-only role for DynamoDB, and then they would not be able to edit it. They would get a failure. They would get a failure message if they attempted to edit it from the Salesforce side. A permissions error. So there is some aspect of AWS that you will have to have somebody with a little bit of AWS knowledge to implement this, because you have to create a key and then with the role, and that Jonathan and I are working through some roles challenges with the new connector for this currently, actually.
Yeah, and I don't know if the problem is on our side or if it's on Salesforce's side. You can still create legacy named credentials, the named credentials that we're used to. Now there's an external credential, a named credential, a permission set. There's multiple things that are required as Salesforce works to do a better job of more granular security when it comes to external data connections. Also, at the field level security, right? You saw me as I was adding the fields. As I created the fields, I assigned those out by permission set. So you still have control within Salesforce of the object and field level permissions of what they're allowed to access within Salesforce. It's that integration itself, right, between the systems that's more controlled by AWS and then reflected in the permission set in Salesforce.
I'll throw this out.
It's a lot of overhead, right?
Yeah, name credentials the new way. It does take a few more minutes to get it configured.
Yeah, but the field level permissions in Salesforce, you have to forgive me, I am not a Salesforce person. So when you talk Salesforce, you're talking Greek to me. It doesn't, that whole conversation before the call, I was like, okay. But with Jonathan stating that you can set field level permissions in Salesforce, it sounds like you can control your permissions to what can be written into the Dynamo from within Salesforce. You don't have to worry about the AWS credentials. You can just give your AWS credential the full access, because it's just a service account that Salesforce is using, and then control your permissions just like you would on any other field in Salesforce, from what I've seen Jonathan doing.
Okay, so it would be like external database, like always, or how is this tied? I'm a little confused there. Suppose if I have a custom object, like whatever the account details or whatever that, so we need to create both the places between Salesforce as well as in the Dynamo. and then map it, and it will be visible as an external data source? As that how it works?
So there's only 3 pieces of information that we need from AWS, right? So the example that I started today was this one, right? I've got a table that exists in AWS that's called Dreamforce Demo. And as part of creating the table in Dynamo, right, a partition key and a sort key are required. Well, the names of those fields and the name of the table are all that's required from DynamoDB. The rest of the setup is in Salesforce, and it's setting up an object just like you would for a custom object, right? I do need the table name and the external data source that's linked into that DynamoDB instance. And I do need my partition key and my sort key, and then I can add whatever additional fields that I need. What I like about this a lot more than other archiving solutions with the custom Apex adapter is I can continue to add fields here over time as I need them, or remove fields, or change field data types. And I can do this dynamically with code via the metadata API without ever having to go back to DynamoDB to make any changes to the database configuration on that side until I need one of these additional fields to be sortable. Right, but it's the easiest way that I've seen yet of managing external data, because I don't ever have to go back and touch the external database configuration.
Okay. How about files? Can we store the file storages as well onto the Dynamo, or it's only a records?
We're only talking records, not files. I think that this question came up earlier, and I think we said, well, you store your files in S3, but you could put a reference to that file inside of Dynamo, or the file itself would not live in Dynamo. Roy, I think you might have had a question. Your video's frozen, but I think you started a question earlier.
Oh, it's frozen? Not frozen for me.
Oh.
No, I didn't have a question. I had a comment.
Okay,
here's
thank
how
you.
I know Jonathan.
Sounds good.
Here's how I know that Jonathan's onto something. Because he shared this with Salesforce and said, "Ooh, you should present this at Dreamforce." And then they got the presentation, and went, this will save our customers a lot of money. So where are we gonna put this guy? And they put him in the absolute worst spot of Dreamforce. They put him on the last day after lunch during True to the Core. That is the absolute worst spot. It's like going up against the Super Bowl, and that's where they put him.
The biggest True to the Core ever.
Yeah. So that's how I know that this is something. And so, but they couldn't renege the invitation to come. It's like, oh man, this could save a lot. This could save them millions and lose us millions. So
well, AWS is a strategic partner with Salesforce, right? They're putting a lot of work into this. This is a best practice with Salesforce. There are large data volume issues, and you can go to Trailhead and read up on those. And one of the best practices that they do recommend is to start offloading to external objects. And they made this a lot easier with this work with DynamoDB. I'm not doing anything tricky here, right? Like this is all okay. They're all within the terms of service. This is how Salesforce should be used. But it's an interesting way, because Salesforce kind of becomes the front end for 2 databases, right? The Salesforce database and DynamoDB, but the front end is exactly the same without any custom code required to make that all work.
Can I ask a quick question? So can you talk about the not sortable thing a little more? Because the 2 related lists look the same, like you could sort by date or whatever. How does that work?
They look that way. The columns aren't actually sortable. Let me see if I can get that back up and share again.
Part of it is on the Dynamo side. I can speak to part of it, because on the Dynamo side, the way Dynamo becomes super efficient is it has a limited number of indexes. You can have what's called the secondary index, which Jonathan and I haven't worked with extensively yet, which is sortable, but everything else is just filtering. It doesn't sort it. But if you actually use you notice there was 2 keys. There was a partition key and a sort key. That sort key is the only thing that is actually sortable when you make a call to DynamoDB. So you're going to make a call to DynamoDB to get records back, and you can only sort by that sort key. So then you have to create another index if you want to sort by another field. It's the same table, and I think in Dynamo or in Salesforce, it would probably be another external object connection because it would have a different partition key and a different sort key is what it would be different, but it'd be the same table. It would be interesting to try that sometime, Jonathan, because I've been wondering about secondary indexes in Dynamo. So you're limited on the amount of number of fields that can be sorted.
But what you'll see here in the Salesforce user interface, the lists are the same, but I configured these fields to not even be sortable in the UI because it doesn't sort them, right, in the API call to DynamoDB. So here, right here, every field can be sorted, right? So we can see the English and Rwandan languages sort. Here it doesn't. However, this is Lightning, right? So we can come in and filter a list view. Well, this is based on the field configuration. So I could say only show me English, or I could say only show me letters that are between, right? We can still apply other filters here. So sorting's not there, filtering is. So for an archival use case, this makes a lot of sense to me. But listen, I've got a customer calling in about a record from last August. Great, we can filter this list very easily to show last August, right? I don't need to sort and scroll. That would be a really inefficient use of my time. So yeah, that's one of the limits right now. And yeah, we haven't explored secondary indexes. They weren't supported when I built this presentation. They may be supported now because we've had the Winter 23 release. Does that help, Chris?
Yes, thank you.
How is the external lookup relationships are maintained? How we can do that? Does it support, or is there any limitations on that?
Yeah, so there's 3 different types of lookup fields when it comes to an external object. A direct lookup field is what I'm using here because I'm literally taking the Salesforce ID and replicating it to the outside database. Right, so it's a Salesforce ID. If you've got an external lookup field on you've got your account ID, right? You've got some unique identifier in Salesforce on your record, right? This is account 456. Well, that's not your 15 to 18 character key. But if it's marked as an external ID, you can do an external lookup to that. So if you got a record in DynamoDB and there's a field that matches that value, it says 456 because it matches that customer, you can configure that lookup as well, even though it's not a Salesforce ID, if it goes to an external identifier field. And the third is you can do an external lookup where you can take a Salesforce object and add a lookup to an outside object, or take 2 outside objects and have them with lookups to each other, as long as that external ID of the external object is the value in that field.
So do we need to do any configuration in the code or adapter for that, or it automatically takes care, or it does what all the actions we need to perform in order to be like that?
Sure, it really depends on the data, how you're populating and maintaining that data. If your outside data source is going to have Salesforce IDs, that's a standard lookup. If it's going to have your own external identifier in the outside data, you'd use an external lookup, right, to the field in Salesforce where that value is expected to match. So it really is about your database design and what sort of values you're going to be matching on for that lookup.
Okay. What about the encrypted fields in the Salesforce? Does it support, or we cannot use that?
Sure. So one nice thing about DynamoDB is always encrypted at rest. That's also a benefit we'll all get when we get moved over to Hyperforce. Everything in Salesforce will always be encrypted at rest once we're on Hyperforce. So that's exciting for all of us who are storing potentially sensitive data. Now, encrypted fields in Salesforce, if we're talking about field level encryption, like that unique field type, I'm not sure I see the connection here between here and DynamoDB for that.
And there was some another question, a few questions in
Thank
chat
you.
about like why, right? Like
Yeah,
why
DynamoDB versus a relational DB. All right, so here's my quick answer. Salesforce has a built-in adapter for DynamoDB. You can build your own from code, right, from scratch, and that's fine. It's a fine way to do it if you like writing code. But if DynamoDB suits your needs, just use the built-in adapter. It's got full CRUD, and they keep building more functionality on top of it.
Gotcha. That makes perfect sense. Yeah, thank you.
Okay.
Is there a way to have a, sorry, one more question.
Sure.
Can you spin up like a test or DynamoDB free, like just to play around with to see if it's something I would want to do?
So we actually didn't have this adapter till last week in our actual organization. So I spun up a new dev org from Salesforce. Anybody you can just keep creating more dev orgs. Right? These are production orgs that allow 2 users, right? But like all the features are turned on. Now, one Salesforce Connect license can be used with any of their adapters. So you can take a Salesforce Connect license and use it for OData 2, or you could use it for OData 4, or you could use it for Dynamo or Athena or Apex. So like you don't have to buy the Dynamo adapter. It's just buying one Salesforce Connect license. But yeah, I would say now on the AWS side, I don't know about. But yeah, for the Salesforce side, every dev org has it enabled already.
DynamoDB.
Okay, so we wouldn't have to have a. Sorry, go ahead.
DynamoDB, AWS does have a threshold of DynamoDB that's free. I believe it's 1 million requests a month are free. I'd have to double check that number, but there is a free level that you could go to AWS, sign up for an AWS account, and then there is a free tier level. And I'll be honest with you, I don't think I've crossed that yet with all of my playing around that I do at home on my personal stuff. I do Internet of Things stuff, and I started using DynamoDB, and I'm creating 100 records every 15 minutes, and I have been for the last 9 months, and they haven't billed me a penny for DynamoDB yet. So I wouldn't be overly concerned about DynamoDB as a free tier for testing, unless you're going to try some massive import like I've seen people doing with millions of records.
The scale of data and the cost. Doug just posted free 25 gigabytes of storage. So I'm not sure when the last time was that anybody got 25 gigabytes free from Salesforce. But that's the point, right? Like there is a way to do cheap cloud storage. DynamoDB has got that, right? And I like that. That's what this solution is keyed off of.
And DynamoDB is billed 2 ways. It's billed by the amount of storage the database takes, and on the read-write requests. So that's the read-write request will hit you much faster than database storage.
It's like
guarantee.
API limits in Salesforce, exactly.
Yeah, because 200 million requests is that's a ton. But one of the things about DynamoDB is when you get outside of the standard sorting and you start doing filtering, your read-write requests multiply very quickly if you don't use your sort keys. I'll give you an example of my Internet of Things stuff. I was trying to sort 50 records, and I was using a different key, and I was getting hits of 60 read requests to pull that back. When I switched my primary key, it went down to a half a read credit to get that same 50 rows back because I was using the sort key as opposed to filtering. Because the way DynamoDB does filtering is it pulls back every record that matches the primary key, the partition key, and the sort key, and then only returns you. It internally goes through and doesn't send you the stuff that doesn't match your filter. That's why the read counts are so high when you do it that way. So,
speaking of testing, are there any plans to make it easier to actually test the interactions? Since I saw it was commented out.
Oh, no, I just didn't write tests because I was skinning my code up just for the sake of presenting. I have to double check on that one. This code was originally the code that I wrote to archive to big objects. Here's the thing. You insert data in a test for a big object, it really inserts, right? It actually inserts the data to the big object. I have to check to see, does it actually insert data during it, like in a test to DynamoDB? So that's the reason why that was commented out, is because this was code that I originally used with big objects till I gave up with that one.
Yeah, which would mean you'd have to then insert and then delete the data or just not test it.
Correct. Although at that point you're testing that Salesforce's adapter is doing what it should. So which I guess you can, but you're not testing your own code at that point, right? You're testing Salesforce's code. I am a big fan. Go ahead.
Have you, like, if you have interactions with the actual DynamoDB that then gets passed back to Salesforce, at least from a view standpoint, are you doing any testing there? Is there ways to break it? Like if you put a bad pick list value and then try and sort on it, well, you can't sort, like filter on it in Salesforce, does that break things?
I'm sure that you could find a way to break things, Paul. I haven't used this in the wild. Like I haven't gotten this out to production yet. So this is our prototype. We just got the license into our organization last week because this right here, the value that's here, it is. I don't want to guess at what the retail pricing is, but it's not insignificant. However, when you're looking at infinite rows of data, right, it's such a good deal if you have a good use case to leverage it. So we'll continue to work through the different data types, and yeah, I mean pick list values accept different values. Well, if it's a restricted pick list, right, in Salesforce setup, and then something else is managing the data in DynamoDB, then I don't know, maybe it shouldn't be a restricted pick list, right? Maybe maybe it was a design problem that you allowed it something else to write to it in AWS. But what does that do? I don't know.
Yeah, all problems that come up when you have multiple cooks making changes.
Yeah, something. Okay, so here's something that I realized. I actually only need one DynamoDB table to archive an entire org, using the partition key. And there's good articles out there about how to design things for DynamoDB. Like, what's the DynamoDB way to structure a table? You don't actually have to set up a new DynamoDB table for this archiving thing. Right, using those partition keys the right way, like the AWS way, you only need to set up the table one time. It can be your single table for archiving everything. So there's interesting use cases that, right, depending on what you want to do with your data, really interesting ways to set that up.
So one more question, like we have a DynamoDB, it has to go through the Salesforce, the source of record. What if I have external system updating a records in Dynamo, does it automatically reflect back to Salesforce? Is that possible, or it is only one directional? It has to go from Salesforce like a back and forth. But
no, actually, yeah, the reason why they asked me to present at Dreamforce is I was the only one who was mastering data out of Salesforce UI. Everyone else who was on the pilot program for DynamoDB was your use case. Hey, we have this big DynamoDB database. Can we see that from Salesforce? And it was just a read-only access to DynamoDB. That's the most common use case of Dynamo. I've already got data there. I just want to see it in the standard Salesforce UI. Easy. Like, that's the no-code part that I started with, right? Is just connect the tables. Just add the table and the columns into Salesforce, and you've got it right there. And yeah, again, this data is not replicated into Salesforce, right? It's virtualized in. But what that means is there's API calls happening in real time as the user interface loads to pull that data in. So if you have another system, right, you got a Lambda updating this data in DynamoDB, or some other system that's writing it, replicating data, that will always be reflected the next time that data is viewed in Salesforce, whether it's, say, scheduled Apex, or whether it's a user loading that page with a related list on it, or a flow that pulls that data.
That's one of the reasons the connector that Salesforce doesn't store any data is DynamoDB delivers sub-millisecond query responses. So when it gets updates, there's no reason for Salesforce to cache it because you're not going to have a slowdown with it because of the way they built DynamoDB. If you do, then Amazon will tell you you have built your DynamoDB incorrectly and you are using it incorrectly, because just the note I put in there, all Amazon.com sales are in DynamoDB. So just imagine a Prime Day or Cyber Monday, how many sales they're going to be doing. All of that runs in DynamoDB. That's why they created it, actually, because this is an Amazon created thing. For those who don't know, it's not like an open source tool. Werner Vogel's the CTO of Amazon. He's a PhD computer scientist, and he wrote a paper about how to do this and presented it to Amazon, and they said, we're going to build that because that sounds like a really cool database structure. So,
does it support record level locking? Like, suppose we have two users updating the same records. It's like, how is that gonna take care of that? Is that like overwrites one over the other, or is that DynamoDB takes care of that?
I think the last update's gonna win, right? Because what's gonna happen, they're gonna there's going to be 2 API calls that come from the Salesforce adapter, right, to change that data. It's going to get changed, and it's going to get changed again when that second person saves their data.
You can set up DynamoDB to have ACID compliance. So that's something fairly new to where you can control transactions. There is such a thing as a DynamoDB transaction that you can actually build. I don't think the Salesforce adapter does it, but Dynamo itself does have a transaction concept.
Okay. Whoever is last update overwrites that one, even though the information was updated initially, it won't get, oh, you need to refresh a record before you update other one, second user. So the way I'm understanding, whoever updates the last one, that is where it overwrites. Is that correct understanding?
I think that's right. I haven't tried that. So that's my best guess. The question in the chat was, does DynamoDB support all data types? There's data types that we talked about earlier that are not supported. Rich text fields with HTML in them, formula fields, and master detail relationships. Those in Salesforce are not supported in DynamoDB. So you can't even configure it in Salesforce setup because it's not an option.
Okay, I'm going to stop the recording. And just a couple